Linear relations between numbers are fundamental to data analysis and predictive modeling. You've encountered linear regression in previous modules where you model relationships between independent and dependent variables. Now we'll explore how these relationships can be extended and applied in more complex scenarios. Let's revisit the concept of linear regression, which models a relationship between a dependent variable and one or more independent variables by fitting a linear equation to the data. The goal is to find the best fitting line through the data points that minimizes the sum of the squared differences between the observed and predicted values. This approach works well for simple, straightforward relationships, but what happens when the relationships are more complex? In the real world, relationships are not always linear, such as the relationship between temperature and plant growth. Sometimes we need to consider interactions between variables or account for nonlinearities that a straight line cannot capture. This is where other techniques such as polynomial regression or multiple regression come into play. These methods allow us to model more intricate relationships by including additional terms or variables. For instance, in polynomial regression, we extend the linear model by incorporating extra powers of the independent variable, which adds the complexity needed for the model to fit curves and not just straight lines, and to reflect more complex patterns in the data. Another important technique is multiple regression, where we include more than one independent variable in our model. This allows us to explore how several factors combine to influence an outcome. For example, if we're predicting house prices, we might include variables such as square footage, number of bedrooms, and distance to the nearest rail hub. Each of these factors contributes to the final prediction, and by analyzing them together, we can create a more accurate and robust model. Understanding how these techniques can be used allows more accurate predictions in complex scenarios. However, it's also important to remember that more complexity isn't always better. Incorporating a lot of variables or higher order terms can lead to overfitting, with the model becoming too tailored to the specifics of the data it was trained on. Hopefully, you've started to gain an understanding of how to harness linear relationships in more advanced ways. Whether you're dealing with complex data patterns or multiple influencing factors, these techniques will enable you to make more accurate predictions and extract more meaningful insights from your data. This is a huge aspect of AI that we've only really had time to brush against, but you can explore it a little further in the skills section.